Hello, my name is Nico Geraldo, and this is my digital sampling week 3 experiment, frequency analysis on king penguins. So, the purpose of this experiment was to find any patterns or distinguishable characteristics of individual king penguin calls, and I chose this topic because I really like penguins, and when I was researching their calls, I found some pretty cool information. So, great penguins, which includes king penguins and emperor penguins, don't make nests. So instead of making nests, they carry their eggs at their feet, meaning that they're not staying in one place all the time. They don't have a home base. The one thing about all birds is that they have a vocal organ called a syrinx, and it is forked, which allows them to create two separate frequencies at the same time. So, and great penguins use this for recognition of their family members. So, some of the required items were a computer, a device to play audio from, which in this case was my phone, a DAC kit, a simple DAC software, and a measuring tape, which the measuring tape isn't completely necessary, but I used it for this experiment. For this preliminary procedure was just setting up the simple DAC software to record how I did. The main thing of note is that I created a high pass filter at 20 Hz to remove low frequency noise that the mic was picking up. So for the actual process of gathering data, I would look for a video of king penguins making noise on my phone, and then I would play an audio snippet of that king penguin playing noise, and then I would switch to hold on the Simple DAC software and pay attention to the power spectrum graph. So I would keep repeating that process until I got two distinguishable peaks on the power spectrum graph. And then I would screenshot that, and I would do that twice for each penguin and three times for the three penguins. So this is the information for penguin 1, and as you can see, it has two distinguishable peaks, and then in both graphs, they're very similar in position. So the something important to note is that this star denotes a more powerful frequency, which was the frequency given by the power spectrum graph. So all the other frequencies are not actually listed on the power spectrum graph, and I found them in a different method using the measuring tape. But something to note is that the distance between the peaks, even though the peaks actually changed frequency, the distance between the peaks was stayed pretty similar. And this trend continues to hold for Penguin 2. So as you can see, the peak frequencies are at different positions, but the distance between the peaks stays pretty similar. It's not as close as Penguin 1, but it's still pretty close, and visually it's also very close. So for Penguin 3, this is where I made a couple of mistakes. I didn't realize this until I was actually analyzing the data, but the distance between the peaks that I had recorded were very different, which means that I let a background penguin. When I paused the power spectrum for recording, the main penguin was dying down and background penguin was coming up in volume. So to fix this, um, I edited the power spectrum graph on the top for call 1 because I noticed that the two secondary peaks were very similar to the peaks from the second call. So using these two secondary peaks in this call 1 revised, I get a very similar frequencies to the call 2. And that can be seen here in the distance. This is call 1 revised, and this is call 2. So that gets a better distance between peaks. So some of the problems I faced were that king penguins live in large groups, so it's difficult to isolate one bird's call in particular, as you can see from Penguin 3. But my main strategy to combat this was to skim the videos while looking at the power spectrum graph, and then I would choose a penguin to record based off seeing two distinct peaks in the power spectrum graph. So that's how I actually chose which penguins to do. And then power spectrum graph shows only peak frequency. So all the other frequencies I found by taking a screenshot, zooming in on the screenshot until the major bars of the power spectrum graph, which are 1,000 hertz apart, were 5 centimeters on the measuring tape. And then I would mark where those are with the minor tick bars, and that's how I found the secondary frequencies. A better solution which makes a lot more sense and is a lot more accurate, would be to set a bandpass filter and isolate the second peak frequency. So that's why you don't necessarily need a measuring tape. For my error analysis, this possible systematic error is based on the microphone. It was reading about 3 Hz lower than what it actually should have been reading. And this possible random error is from using the measuring tape. Because all the minor ticks were about 20 Hz if I set 1000 Hz to be 5 centimeters. So half of that would be 10 Hz. In conclusion, the frequencies of the penguins changed, but the distance between them seems similar for each penguin. So that means they have around a voice. And they all stuck around the 550 Hertz range, like give or take 100 Hertz. So, and one thing I learned is that if I were a penguin returning from a fishing trip, I definitely would not be able to find my family. And then these are my sources.